Welcome to today's Explainer. We're jumping straight into something every single one of us has dealt with, the Java error lifecycle. If you've ever spent hours staring at a screen, completely baffled by a sudden failure in your application, well, you are in exactly the right place. Today, we're tracking the journey of a bug, mapping out exactly how and why Java applications fail, literally from the very first line of code you write all the way through to execution. It's the ultimate question, isn't it? We have all experienced that shared, deep frustration of writing code that we swear is absolutely perfect, only for it to just refuse to work. But what if I told you that these failures aren't just random acts of chaos? They actually follow a highly predictable structure. And by understanding this structure, you're going to dramatically cut down your debugging time. Okay, let's dive into this. Here is our game plan for today. First, the anatomy of an error. Then we'll hit compile time, the syntax trap, runtime, the unexpected crash, logical, the silent saboteur, system meltdown, JVM errors, and finally, error versus exception. All right, section 1, the anatomy of an error. Before we get into the weeds here, let's just establish our baseline. What do we actually mean when we say error? Simply put, an error is a problem in a program that causes it to fail either during compilation or during execution. These failures happen for a few key reasons: incorrect syntax, bad program logic, runtime issues, or complete system and JVM failures. Those are the stakes we're dealing with. So let's see how this maps directly onto your actual day-to-day workflow. Your code's lifecycle basically has 3 distinct phases. First, you write and compile. Second, you execute the application. And third, you evaluate the results. The different types of errors we're about to unpack map perfectly onto these 3 specific phases. Which brings us to Phase 1 and Section 2, compile time, the syntax trap. Compile time errors are caught by the Java compiler before your program even gets a chance to run, so right at the start of our lifecycle. The most common culprits? They're essentially foundational grammar mistakes. We're talking a missing semicolon, misspelled keywords, trying to use variables you haven't declared, or forgetting your curly braces. Because Java is such a strongly typed, highly structured language, it just flat out refuses to proceed if the grammar isn't totally perfect. And this brilliantly illustrates the point. This code snippet is incredibly simple. We're literally just trying to print the word hello. But if you look closely at the very end of that print statement, yep, there's a missing semicolon. It is a tiny, tiny oversight, but in Java, that's a hard stop. Boom! Immediately, the compiler spits out this complaint. Semicolon expected. Honestly, what's great about compile time errors is that Java actively prevents the syntax trap from sneaking into the execution phase. The program simply will not compile, which means you're forced to fix it right then and there. Moving right along to Section 3, runtime, the unexpected crash. Okay, so now we've reached the execution phase. At this point, your code compiled perfectly, the syntax is flawless, but the crash happens the exact moment the code actually tries to perform the work. Take dividing integer a by integer b. Syntactically, that is completely valid Java. The compiler gives it a green light. But because b is 0, we are asking the computer to do the mathematically impossible. You'll also see this with things like accessing an invalid array index or the infamous null object access. The second execution hits that impossible math, you get a crash output. In this case, an arithmetic exception for dividing by 0. The absolutely crucial point here is that runtime errors are very often referred to as exceptions. And unlike compile time errors, you can actually anticipate and solve these by wrapping your risky code in exception handling blocks, specifically using try-catch statements. Section 4, logical, the silent saboteur. We are now in Phase 3 of the life cycle, evaluating the results. And guys, logical errors are arguably the most insidious type of bug out there. Why? Because the program compiles perfectly and it runs without crashing at all. But it produces the completely wrong results. Imagine your length is 10 and your width is 5. In the wrong code, accidentally typing a plus sign instead of a multiplication sign outputs an area of 15. The correct code uses the asterisk, giving the actual correct output of 50. The computer didn't crash, it just blindly, happily executed your incorrect math. Next up, Section 5, System Meltdown, JVM Errors. Sometimes the issue isn't your syntax, and actually, scratch that, it isn't even your application's logic. These are serious, catastrophic errors generated by the Java virtual machine itself. They happen when the runtime environment just completely fails, and normally your app can't do anything to handle them. The heavy hitters include an out-of-memory error, like when you initialize a gigantically massive array that drains all available memory. Then there's the sheer panic of a Stack Overflow error caused by an excessive recursive method call that won't stop. We've also got no class def found error or just a broad virtual machine error. When these strike, your application is basically doomed to shut down. Finally, Section 6, Error versus Exception. This brings us to a major source of confusion for developers, and honestly, a guaranteed technical interview question. Let's draw a clear line in the sand. An error indicates a severe problem, usually caused by the JVM or the system itself. Crucially, they usually cannot be handled. You can't just try catch an out-of-memory error and keep humming along. An exception, however, indicates a condition caused by your application logic or runtime environment, like our divide by zero example. Exceptions are recoverable problems that absolutely can and should be handled using try-catch blocks. To bring this whole shebang together, let's look at this summary to cement exactly when and why these bugs show up in your journey. Compile time errors happen during compilation, stopping you in your tracks for things like a missing semicolon. Runtime errors strike during execution, throwing exceptions for issues like a null pointer. Logical errors happen when everything runs smoothly, but the logic is flawed, so you get a bad result. And JVM errors, that's when the environment itself goes down like running out of memory. And that leaves us with one final thought. Look, you can't stop all bugs from being written. It's just part of being a developer. But armed with this structured map of the Java era lifecycle, you are no longer guessing in the dark. Whether you're debugging a super stubborn application at 2 a.m. or prepping to ace an upcoming technical interview, you now know exactly where to look. So the only question is, are you ready to catch the next one? Thanks for hanging out for this explainer, and happy debugging.